Welcome to Infrastructure for MLOps. Here we will cover the necessary infrastructure component for MLOps, including the cloud platforms, containerization, orchestration with Kubernetes, and setting up local environments. Let's look at what we will cover here. First, introduction to cloud platforms for MLOps, AWS, GCP, and Azure. Containerization with Docker. We'll do Kubernetes for orchestrating ML workloads, setting up your local MLOps environment, and finally, we'll look at hands-on of setting up Docker and Kubernetes environment. So let's jump into introduction to cloud platforms with MLOps. We'll look at three different cloud platforms: AWS, GCP, and Azure. Now, cloud platforms provide essential infrastructure for building, training, and deploying machine learning models. Let's compare the key features of AWS, GCP, and Azure for MLOps and discuss how to set up the cloud infrastructure. First, comparing key features of cloud platforms. And the first one is AWS, which is Amazon Web Services. Now, the services that are available with AWS include SageMaker, which is an end to end service for building, training, and deploying ML models. We have Lambda, which is serverless compute for deploying lightweight ML models. And then we have Elastic Kubernetes Service, which is EKS, which is managed Kubernetes for orchestration. And we also have S3, which is storage for data and models. Now, the key features include first, it's highly scalable with global data centers. We have strong integration with enterprise tools and security, and extensive automation with services like SageMaker pipelines. What about pricing? Pricing is pay as you go with some free tier options for light use. Next, let's look at GCP, which is Google Cloud Platform. The services that they provide are, we have the AI platform, which is a comprehensive platform for training and deploying ML models. We have BigQuery ML, which is SQL based model training directly in BigQuery. We have Kubernetes Engine, which is GKE, which is a managed Kubernetes for ML workloads. And then we have the TensorFlow Enterprise, optimized for TensorFlow deployments. Now let's look at some of the key features. First is deep integration with TensorFlow. Next, second, it has strong data analytics with BigQuery and Dataflow. And it is AutoML are pre-built AI services for faster deployment. What about pricing? Pay-per-use model with strong free tier offerings for AI platform. Next, let's look at Azure. The Azure services available are Azure Machine Learning, which is managed ML lifecycle service. We have Azure Kubernetes Service, which is AKS, managed Kubernetes clusters. We have Azure Functions, the serverless for lightweight model deployment, and we have the blob storage, which is data and model storage. Some of the key features include integrated with Microsoft services like Office 365 and Azure DevOps. We have strong tooling for MLOps with automated pipelines and good support for enterprise customers. What about pricing? Pricing is competitive pricing with free tier services for ML. Next, let's look at setting up cloud infrastructure for MLOps. Now, first, let's look at the steps to set up infrastructure on AWS. First, you have to set up an AWS account and create an IAM role for your access control. Next, you will look at use S3 for storing training datasets. Next, you will train models on SageMaker and deploy endpoints. Finally, set up your EKS, which is the Elastic Kubernetes service for orchestrating ML workloads. Next, let's look at steps to set up infrastructure on GCP. For this, you'll have to first create a Google Cloud project and enable the AI platform. Next, you'll go and store data in cloud storage and train models using AI platform. And finally, use the GKE, which is the Google Kubernetes Engine, for large-scale orchestration. Finally, what are the steps to set up infrastructure on Azure? You'll have to first create an Azure ML workspace for tracking models. Next, you'll use Azure Kubernetes Service AKS for managing models at scale. And finally, leverage Azure DevOps to automate MLOps pipeline. Containerization with Docker. Now, Docker is a key technology for ensuring consistency and reproducibility when deploying machine learning models. It packages code, dependencies, and runtime into portable containers. Some of the benefits of using Docker for reproducibility includes consistency across environments. Docker ensures that the model runs the same way in development, testing, and production environment. No more works on my machine issues. Dependency management. Docker handles all the dependencies, which are the Python libraries, be it system packages, within a single image, avoiding version conflicts. And scalability and portability. Docker containers can be easily scaled across different environments, including cloud providers like AWS, GCP, and Azure. Let's look at creating Docker images for ML models. Now, for that, you need Docker file for ML model. You'll have to create a Docker file to package your ML models code into an image. You'll see that in our hands-on. Next, you have to build and run the Docker image. That's pretty much it. That's all you need to do. And we will be doing this in our hands-on at the end of this section. Next, let's look at Kubernetes for orchestrating ML workloads. Now, Kubernetes or K8s automates the deployment, scaling, and management of containerized application. It's essential for scaling ML workloads and managing distributed training. Basic concepts of Kubernetes. We have the pod, which is the smallest deployable unit in Kubernetes, typically a single Docker container. Then we have the node, a worker machine where pods run. Above that, we have the deployment, ensures that a specified number of pod replicas are running at any time. We have service, which exposes an application running on a set of pods to the internet or within a cluster. Let's look at setting up Kubernetes for distributed ML workloads. First, you'll have to install Kubernetes. If you're setting up a local cluster, you can use Minikube or Docker Desktop to run Kubernetes locally. Next is deploying ML workloads on Kubernetes. You create a deployment.yaml file to define the pods and services in this particular case. And as I mentioned, we're going to do this in our hands-on in a little while. Finally, deploying on Kubernetes. You have to apply the deployment file and expose the service. Let's look at setting up local MLOps environment. While cloud-based infrastructure is critical for large-scale workloads, local environments play a key role in experimentation and development. What are the tools and practices for local development? First, Python virtual environments. Always use virtual environments like VENV or Conda to isolate dependencies when developing ML pipelines locally. Local databases and storage. Use lightweight databases like SQLite for local development before switching to more robust cloud-based databases. Docker for local development. Use Docker Compose to orchestrate multi-container environments, example running a ML app and a database targets together locally. What are the best practices for local MLOps? First, unit test and integration test. Write your unit test for model training code and integration test to verify the pipeline functions as expected in your local environment. Version control. Always use Git or similar version control tools to manage code experiments and pipelines. Automated builds. Use tools like Docker and Jenkins to automate builds for reproducibility. Finally, let's look at our hands-on where we will be setting up Docker and Kubernetes environment. Here, we will be setting up the Docker environment, we'll be installing Docker, and we'll be creating a simple Docker file. Then we'll build and run the Docker image. And finally, to set up Kubernetes environment, we will install Kubernetes and we'll deploy our ML models locally on Kubernetes. So let's get started. So let's start with our hands-on, where we will be using Docker and Kubernetes for containerizing and deploying a simple ML model. So first step is to set up the Docker environment. First, make sure that you have Docker installed. If you do not, you can go to docker.com, go to products and Docker desktop, and from there you can download Docker. So I have already Docker installed and it's running. So I'm going to go to dashboard. For the sake of this video, I have deleted everything. There's nothing, no containers, no images right now on my Docker container. So we'll start from scratch. So this is what you should be seeing when you install it. Next, let's create a simple ML model and Flask app which we will be deploying. So for that, I am going to go to my desktop, create a new folder. I am going to call that folder ML underscore model underscore app. I will open that in Sublime Text, and inside here I'm going to create a new file. I'll save it as model underscore training.py. So I have that. Now inside this, I will, based on the previous videos that you've probably seen, I'm going to create a model training Python file, which will initially, we'll start with import joblib. Joblib is a Python library used for saving and loading large Python objects, particularly machine learning models. In this case, it will be used to save the trained random forest model to disk so that it can be reused without retraining. So I'm going to import some more stuff. We have already gone through it, but I can go over it again. Sklearn.ensemble import random forest regressor. So this imports the random forest regressor class from sklearn. A random forest is an ensemble learning method that builds multiple decision trees and averages their predictions for more accurate and stable results in regression tasks. This will be used to predict housing prices in this particular example. Next one, from sklearn dot datasets import fetch underscore California underscore housing. This imports a function that retrieves the California housing dataset, which is a dataset containing real-world housing data from California. The dataset is used for regression problems where the goal is to predict the value of houses based on features like the number of rooms, location, etc. Next one, from sklearn dot model selection import train underscore test underscore split. So this function is used to split a data set into two parts, a training set and a testing set. The training set is used to train the model and the testing set is used to evaluate its performance on unseen data. And finally, sklearn dot pre processing import standard scalar. This imports the standard scalar class, which is used to standardize features by removing the mean and scaling them to unit variance. This is important for models like random forest as it helps the algorithm process the data more efficiently. Now let's go ahead and load the California housing dataset. Housing equal to fetch California housing. So this line loads the California housing dataset from sklearn. The dataset contains 8 feature columns such as average number of rooms, house age, etc., and one target column which is the house price. The dataset is loaded as a bunch object which is similar to a Python dictionary and contains the data and target variables. It has the following attributes as the housing.data, which is a 2D array of feature values which are independent variables, and it has housing.target, a 1D array containing the target variable which is housing prices. So let's go ahead and split the data. So I am going to say x underscore train comma x underscore test y underscore train comma y underscore test equal to train underscore test underscore split housing dot data comma housing dot target comma test underscore size equal to 0.2 and random underscore state equal to 42. So in this particular case, this splits the data into training and testing sets, as the names mention. Now we have the housing dot data as one of the parameter here, which is the feature. This is the feature matrix, which has independent variables. Then we have the housing dot target, which I mentioned is the target variable, which is the house prices. Then we have here test size is 0.2, which specifies that 20% of the data will be used as the test set, which means 80% will be used for training. And then we have the random state is 42. This sets the random seed, ensuring that the split is reproducible. The same split will be obtained every time the code is run. And this kind of outputs, we have the X train, which is the feature matrix for the training set, which is 80% of the data. We have X test, which is the feature matrix for the test set, which is 20% of the data. Then we have the target variable for training set, and we have the target variable for the test set. Next, let's go into for scaling the features. So for that, I'm going to use the scalar equal to standard scalar, and I'll also do the other stuff, which is x train underscore scaled equal to scalar dot, I think this is not right, dot fit underscore transform x underscore train, pass that there, x underscore test underscore scaled equal to, we get from scalar dot transform and pass it x underscore test to it. So why scale the features? Scaling ensures that each feature contributes equally to the model. Without scaling, features with larger ranges like house area may dominate the learning process and distort the predictions. So what we are doing here is we are saying scalar equal to standard scalar. This creates an instance of the standard scalar class, which will be used to standardize the features. Then we have xtrain scalar dot fit transform xtrain. The fit transform method first computes the mean and standard deviation of the training data, then scales it. The transformation is applied only to the training data at this point. After scaling, all features will have a mean of 0 and a variance of 1. Then we have the transform function here. This method applies the scaling that was computed on the training data to the test data. It's important to not fit the scalar on the test data, as this could lead to data leakage, that is allowing information from the test set to influence the model during the training. Next, let's go ahead with training the random forest model. So I'm going to go here. I'm going to say model equal to random forest regressor n underscore estimators equal to 100, and then random state equal to same 42. I'll also do the fitting of it, model dot fit x underscore train scaled and y underscore train. So in here, this initializes a random forest regressor with n estimator equal to 100. Now this specifies that the model will consist of 100 individual decision trees, and random state equal to 42 ensures that the results are reproducible. Random forest introduce randomness, example in sampling data and features, and setting a seed ensures consistent behavior, as mentioned earlier. Finally, the model.fit, this trains the random forest model using the training data, which is x train scaled, and target values, which is y train. The model will learn patterns in the data by building 100 decision trees and combining their predictions to minimize the prediction error. So let's go to the next one, which is saving the trained model to a file. So I am going to use that joblib that I imported, and I am going to say joblib dot dump model, and I'll give a name to this model. I'll call this model dot pkl pickle file, and then print model trained and saved to model dot pkl, just for knowing that it went through the entire steps. So joblib.dump, this saves the trained random forest model to a file named model.pickle. Now, why save the model? After training the model, you may want to save it to disk so that you can reuse it later. Example, for making predictions without having to retrain it. This is useful when deploying models in production environments, and that's what we will be doing with this later. So model.pkl is a binary file that contains the serialized version of the trained model. It's also called as pickle file, pkl, and that's why the extension pkl. Then finally we print a message indicating that the model has been successfully trained and saved to this file, just to give us an idea that it went through all these steps. So let's save it, and next step is to create the Flask Python file. I'll save it as app.py. I'm going to start with from Flask import Flask, comma, request, comma, JSONify. Here, Flask is a lightweight web framework used to create web applications and API in Python. It provides tools and functionalities to handle web requests and responses, and that's what we want to do. Eventually, we want to put our pickle file that we created or prediction files uh, and call it using a predict API. So that's why we are using Flask here. Now the Flask, this class is used to initialize the Flask application. We have request. This object is used to access incoming HTTP request data. The example, data sent with a post request, which we'll be doing for calling making predictions. Then finally we have JSONify. This function is used to convert the Python dictionaries or data structures into JSON format, which is the format typically used for API responses. So that's what we will be printing it out if you have never, if you're not familiar with it. Next, I'm going to import joblib and import numpy as n numpy as np. So what I'm doing here is joblib is that Python library used for saving and loading large Python objects, including machine learning models, and that's what we have this here for. So we can load that model.pickle file, which we previously saved in the in model training file. Next, we are using NumPy, which is NumPy is a popular Python library used for working with arrays and numerical data. It provides a fast and efficient way to manipulate and process data, which is essential when preparing input data for the machine learning model. So let's load the trained model. Now the thing is, we have not run the previous file, but I'm just gonna go ahead and load model.pkl. So this line loads the previously trained model, machine learning model, from the model.pkl file. The file contains the serialized model saved using whatever we used, joblib.dump here. Once loaded, the model is ready uh, to make predictions on the new data. So let's first, before we even go forward, let's open a terminal, go to desktop, clear. We create an environment, Python -m virtual environment. I'm going to call it model environment. And then I'm going to activate it, saying source /bin/activate. Now once that is activated, let's go back here and look at, we have joblib and sklearn. So I will go ahead and first say pip install joblib, and then I need the skikit learn. So I'm going to say skikit learn and install both of them inside this environment. Once it's done, I am going to clear this out, and now I can run. It's inside the folder score, and the file is called model. Looks like I used the wrong, there's a typo, ran done. Okay, that's why. I'm gonna make sure that it's fine both places. Save it, go back, clear it out. It's also better to just go inside the folder. So I'm going to just go in there because I'm going to pick it up from inside the folder too. So say Python model training.py. Okay, it completed because I know model trained and saved to model. I can save ls it and I see that model pickle file is ready. So this kind of completes our model training. Now next step, which is this will load that particular model, and the next step here is to initialize the Flask app. So I'm going to say app equal to Flask underscore underscore name underscore underscore. So this line initializes a Flask web application. The Flask constructor takes the single argument, which is underscore underscore name underscore underscore, which represents the name of the current module, the name of the Python script. Flask uses this name to locate resources like templates or static files and configure the application. The app variable is the Flask application object, which will be used to define routes and handle incoming requests. Now let's next define the prediction endpoint. So for that, I am going to say @app dot specify the route and slash predict, and the methods used for this is post, and I'll define the predict function here. But before that, let's go through this. So app dot route, this line defines the route. This line defines the route in the Flask application. A route is the URL path that clients or your users or systems can use to interact with the API. The slash predict, this is the endpoint URL path that users will send requests to when they want to get a prediction from the model. I called it slash predict. You can call whatever you want. And methods equal to post, this specifies that the endpoint will accept post request only. Post requests are typically used when sending data to a server. Example, input data for the model. So that's what we'll be sending. And finally, def predict, or this defines the predict function. That's how you do it in def is what you use for functions, which will handle requests sent to the slash predict endpoint. This function will be called whenever a post request is made to predict. So now let's go ahead and handle the data. So inside the function, I am going to say data equal to request dot get underscore JSON. So this line retrieves the input data sent in the post request. The client sends data in JSON format as part of the request body. When I say request.getJSON, this method parses the incoming request data as JSON and returns it to the Python dictionary. The input data is stored in the data variable. This data will likely contain features like input values that the model will use to make predictions. So let's go ahead and pre-process the input data. For that, I'm going to say features equal to np dot array data features dot reshape 1 comma minus 1. Now this features equal to np array, what it does is it takes the data features. The JSON input is expected to contain a key called features. This key stores the actual data that the model will use to make a prediction. Example, an array of housing features like median income, number of rooms, etc. The np.array data features, this converts the list of features from the JSON request into a numpy array, which is the data format that machine learning models like scikit-learn models expect as input. Then we have dot reshape 1 comma minus 1. This reshapes the array into the correct shape for the model. The model expects a 2D array where each row is a separate example. By using reshape 1 comma minus 1, we create a 2D array with one row and however many columns are necessary, the number of features. This is important because even though we are only sending one data point for prediction, the model expects the data in the form of a 2D array. So let's make the prediction next. So I am going to say prediction equal to model dot predict pass the features at array object 0. So the model dot predict, this line uses the loaded machine learning model to make a prediction based on the input features. The predict method takes the features as input and returns the predicted values. The features here, this is the pre-processed input data, a 2D numpy array that we have that was passed to the model. And then this last part, if you have not familiar with arrays, since model.predict features returns an array, even if we are only predicting a single value, this in square brackets of 0 is used to extract the first and only predicted value from the array. The predicted value is stored in the variable prediction. Now, next, let's return it. Return JSONify, and I am going to put the curly brackets and say prediction is equal to whatever the prediction value is. So here we return the return the prediction, and then we also JSONify it. This function converts the Python dictionary into a JSON format response. In this case, the dictionary has a single key, which is prediction, and the value of this is prediction result from the model. The response is sent back to the client will look something like this. It'll say prediction colon and then 3 point whatever something like this. This will be the predicted house price or whatever the model is trained to predict. In our case, it is the house price. Next thing is running the Flask app. Now to run the Flask app, you say if underscore underscore name underscore underscore equal to underscore 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 main underscore underscore colon, then app dot run host equal to 0.0.0.0, the IP port equal to, usually I use 5000, but I'm going to use 5001 because in Mac sometimes 5000 is taken. So the name equal to main, what's happening there in the if. This line ensures that the Flask application is only run when the script is executed directly. If the script is imported as a module in another file, the Flask app won't be started. The values here, app.run, this method starts the Flask application built in development server, the host 0.0. This makes the application accessible from any network interface on the machine. It allows external machines to access the Flask app, not just the local machine. The port equal to 5001, this specifies the port on which Flask app will be available. In this case, the application will be accessible using something like http colon slash slash localhost colon 5001, somewhere over there. It's Python. So yeah, so something like that. So that completes our Flask application. Make sure it's saved. And another file that we need here is new file. I'm gonna save it as requirements.txt. If you are familiar with it, you already know what I'm doing. Flask equal to, I'll have to give a version of Flask, so I'll be using the latest one at this point, 3.0.3. I will use, I'll say that I want joblib equal to 1.4.2 and skikit learn that works with these is 1.5.2. So these are the ones that will work for me. Now this is the dependencies for the project, which is used by Docker. So we'll be creating this. Now next one that I need is the Docker file. New file. So we'll create this Docker file, which is called as docker and file Docker file, that defines how the Docker image should be built. Ensure that the latest version of your Python and Flask are used. That's what I'm doing right now at the time of recording of this particular video. Now next I am going to, inside my Docker file, I will first I'll say from Python colon 3.9 dash slim, that's the version that I want to use. Working directory should be slash app, that's what you need to create. Next I'm going to say copy the requirements dot txt file to this particular wherever docker install. So you copy the requirement file into a file and also install the dependencies. So to run, I'll say run pip install. First I have to make sure that upgrade pip, that we have the latest pip. Then I want to say pip install -r requirements dot text. So whatever is inside that, that will be run after that. Next I'll say copy the rest of the application code. So for that, since it's in the same folder, dot page dot, and then we'll expose the port. Expose, what is the port that we used? We used 5001, and command is command to run the Flask app, which is python, and the name of the file app.py. So once this is created, make sure it's saved, and then we'll build and run the Docker image. So for that, I'm going to go to my terminal, clear out everything, and I am going to give the command docker build -t ml underscore model underscore app and dot. So what this does is the Docker build instructs Docker to build the image dash t ml model app. It tags the image with the name ml model app, so we can see the application on Docker, and then dot refers to the current directory as the build context. So I'm going to run that, and it says requirement.txt is not found. The reason is it's not called requirement, it's requirements. Requirements here is the typo. So do that and run it again. It's going to take some time to install and run, and then once it completes, if you don't see an error, everything went well. If you see any errors or issues, leave a comment or search online, and you'll probably find the solution for that. But yes, leave a comment to me in this video and I'll get back to you. Next thing is running the Docker container. Now you can run the Docker container using the following command, which is mapping port, which we use docker run -p 5001 colon 5001 ml underscore model underscore app. So this maps to port 5001 inside the container to port 5001 on your local machine. So that's perfect. It says import Flask from Flask, so which means here said Flask. So I'll try to run it again. So now that I've changed it, I have to build it again. So I'm going to go ahead and build the application and run it again, and it's running now. So if you see this is a development server. Do not be scared, it's not a production. That's why it's showing me this message, and it says this is where it's running right now. So now if you want to test it, I can open another tab here, and inside this I'll make sure that I copy this port number, and here I can just use curl command to run a API call. So I need post the URL and the predict option dash headers. So what all headers do I need? Usually I pass the content dash type as application slash JSON, and then I use the data set that I have in there as JSON with, as I mentioned, we need to send features. So I'm going to say features colon, and inside that I'll give some values. I have some values from my project, which are the house values, house price, not the house values, but based on the house pricing and stuff. These are the different values in the particular housing. You can open the Excel file, or you can look at the housing data, and that's what you will see over there. Once I'm done with this, close this. So these are the values that I'm saying. Based on these values, can you predict the house price? And I'm going to run this. I think I and it says prediction is 3.59952. So that's what the price of the house is based on this model. So the next thing, so this kind of completes our first part, which is setting up the Docker. Now, we next thing that we want to do is set up Kubernetes so we can deploy our model that we've created. So I am going to clear this out. I don't need this anymore. I'm going to close the server. As you can see, it also said the server actually that ran said that there was a request made at this particular date at this particular time, and this was the API call that was made. I'm going to switch this off by saying Control C, clear, and that kind of takes care of that. Now, setting up our Kubernetes environment. Now, to set up the Kubernetes environment, let's deploy the Dockerized ML model on a Kubernetes cluster using Minikube. Now, first thing that you need to do is install Minikube and kubectl. You can look at the how to install Minikube using the official installation guide in to install Minikube on the website. But I've already done that before, so I know it. You can use Homebrew, which is brew install kubectl. That's how you install the Minikube. So it says as I mentioned, since I already installed it, it's saying already installed. Now I am going to say start the Minikube. So Minikube start. So it says it's done. So it took some time and it went through the entire thing and did whatever it needs to do. So here we have successfully installed Minikube and kubectl. Now the next step is to create Kubernetes deployment and service files. So I am going to clear this out, and I'm going to create first the deployment YAML file. So for that, I'm going to go back here on the same folder. I'm going to create this deployment.yaml file. So in this particular file, first I will have to specify the API version that I'm using. API version specifies which version of the Kubernetes API you're using to create the resource. The API. So let me write it first so you can visualize API version apps/v1. So the API version defines what kind of objects and functionalities are available for this particular configuration. The apps/v1 is the version for creating deployments which are part of the apps group of resources in Kubernetes. The apps v1 API version is stable and includes support for managing and scaling applications using deployments. Next thing is kind. What kind of deployment is this? And I am going to specify that this is deployment. So kind defines the type of Kubernetes resource that you want to create. In this case, it's deployment. So deployment in Kubernetes ensures that a specific number of pods are running, updates them when necessary, and can roll back to previous versions if needed. Deployments are used to manage stateless applications like a machine learning model service, which is what we are doing here. Now, next thing is that we'll specify the metadata, and for that I need a name. That name will be, I always try to keep it as same as my app model name, ml-model deployment. So metadata contains information that helps identify and organize the deployment. The name of the deployment is ML model deployment. This name will be used to identify and refer to the deployment within the Kubernetes cluster. Example, if you want to scale or manage this deployment, you will use the name ML model deployment in your kubectl commands. Next, what we need is spec. So I am going to go here and say spec. This is the spec. This section specifies the desired state of the deployment. It defines how many replicas, that is pods, should be running, and the configuration for the containers. So for this, I am going to say that the amount of replicas that I need is 3. Now, replicas defines the number of pods, replica as I mentioned, which are instances that Kubernetes should run for this deployment. In this case, the 3 replicas of the pod will run. This means that Kubernetes will ensure that 3 instances of the machine learning model service are running at all times. If one pod crashes, Kubernetes will automatically spin up a new one to maintain the desired number of replicas. Next thing that we need is selector, and that is match labels app of ML model. So selector, this tells Kubernetes which pods are part of this deployment. It uses labels to find and manage the correct pods. Match labels, this ensures that Kubernetes selects only the pods that have the label app ML model. Only pods with this label will be managed by this deployment. The selector is important for scaling, rolling updates, and ensuring that the correct pods are part of the deployment. Next, we need template. Template, say metadata, labels, app is ML model. So the template, this defines the blueprint for the pods that deployment will create. Every time Kubernetes creates a new pod, it uses this template to define the pod's configuration, such as the containers it will run and the associated settings. Metadata here refers to the pod level metadata. Labels, this adds a label to the pods. In this case, each pod will be labeled with app ML model so that Kubernetes can identify these pods as part of the ML model deployment. This label is matched by the selector defined earlier over here. So next is we need a spec for template. Inside that I'll have containers. So let me completely write this containers, right? And containers I have name, which is ML model dash container. I have image is ML model underscore of, that's not my ML underscore model underscore app latest, that's coming from Docker. Image pull policy is equal to never, and then ports equal to, sorry, container port, and if you remember this, we used 5001. So this part of the template defines what the container inside the pod will look like and how it will behave. The containers defines the containers that will run inside each pod. Pods can have one or more containers, but in this case we have a single container inside each pod. The name is, this name is given to the container, so the ML model container name, that's what we have given. The image that this specifies the Docker image that Kubernetes should pull and run in the container. The image contains the application and its dependencies. ML model app latest, this tells the Kubernetes to pull the ML model app Docker image using the latest tag from the Docker registry. The latest tag means that it will pull the most recently built image or the latest version in the registry. You can specify a version number also if you want. Kubernetes will try to pull this image from Docker registry like Docker Hub unless you are using a local registry, example Minicube's local Docker environment. And I mentioned that image pull policy is never. And then finally ports is container port 5001. This exposes port 5001 inside the container. This is the port where the Flask application or whatever service you're running inside the container is listening to. We are using Flask, so we are safe there. When traffic reaches this pod, Kubernetes will route it to port 5001 of the container, which will handle the incoming request. So that's kind of completes our deployments.yaml file. The next file that we want to create is service.yaml. So I'm going to save this as service.yaml. And inside this, we have almost same stuff kind of things, but let's say API version. I'm going to specify as v1. I'm not going to explain everything again. What is kind, service, metadata, and give it a name, and I'll give a name of ML model service. Always be consistent with your namings. And next thing, I need to provide the specification. So spec up, and I'll say type of specification. In this case, I'm going to say load balancer. because this exposes the service via an external IP. So next I'm going to say selector, and my selector app, which is ML dash model. Next is ports that I want to use. I'll say protocol is TCP protocol that I want to use. Port that I want to use is specify 8080, and target port that I want to use is 5001. So that kind of takes care of my service file. Now we have to deploy the model using Kubernetes. So first we'll push the Docker image to Minicube's Docker daemon. Ensure that the Docker image is available to Kubernetes by using Minicube's Docker environment. So for that, we'll go here. I'll say evaluate dollar Minicube Docker. So this will make sure that we are checking. No problems. Perfect. Now I'll say docker build dash t ml underscore model underscore app. So I recently built it, but better to build it again. It's going to go through the same steps. And once this is done, I am going to, let's first clear it out, and then I'll say kubectl apply. So this, what I'm trying to do is apply the deployment and the service using kubectl to apply the configuration files and deploy the containerized model on the Kubernetes cluster. So to do that, I'll say this, and I'll say deployment.yaml file. So it gave me an error here, which error when creating deployments. YAML deployment in version v1 cannot be handled as deployment. Strict decoding error, unknown field, spec.template metadata label. So we can go here and you'll see the problem was, instead of labels I specified label. Let's try that again, and that's created. That's perfect. Next one is we'll have to do for the service. So I'm going to say apply service.yaml, and that is created too. So perfect. So both our deployments and service are created, so that's good. Next I need to get the external IP address. So for that, first clear it out. Say minikube service ml dash model dash service dash dash URL. So this will give me the URL for this particular service. So it's something similar to what we did before we put it on localhost and a particular port, but this gives me on the Kubernetes environment of where that particular app is running. So once this is done, now I can do the same thing, open another tab, and I can run that same command, which was curl -x post, and then give the IP address. So I'm going to copy this, paste it here, slash what was that, predict, and the header files, header values I gave, I think content type application JSON. So content type application slash JSON, and then for the data I'll say -d, and I pass, as mentioned, that we need features. Let me get that from my previous code. Features, and this was what I gave. I think everything is perfect. Let me run it. It says prediction 3.5952 is the price. So that's what ran over here, and that's what we saw. So that kind of worked, and this kind of concludes our video where we have containerized a simple ML model using Docker. Then we deployed the Dockerized model on a local Kubernetes cluster using Minikube, and finally we exposed the service and tested the deployment model through Kubernetes. So if you had any problems or had any issues with this particular video or walking through whatever I did here, let me know in the comments and I'll get back to you. Thank you.